Hello everybody, my name is Alexis NIYOMWUNGERI. I am a TVET trainer at College de Bethel APARUDE. Now I would like to introduce the module called Basics and Fundamentals of Database. Now, first of all, I think all students at your home, you are aware. Yes, because this time of coronaviruses are not easy, but I'd like to greet you and tell you that you have to respect all measures that our government provided to prevent the spread of coronavirus. Now, I am a trainer in the trade of computer application and software development, and based on the chronogram, the second term we should study the module called Basics and Fundamentals of Database, as you see here on the screen. We are facing the challenge of coronavirus because there is no possibility to attend classes where students should come in the classroom and the trainer comes and then start delivering. This is the reason why I would like to use this way to help you, because the second term should be started, but you know the issue. Now let's start. This module is called Basics and Fundamentals of Database, as you see, and describes the skills and knowledge and attitude to be acquired by the learner to analyze database requirements, design and build simple database. It means at the end of this module, you as a learner, you will be able to describe basics and fundamentals of database and build a simple database. I would like also to remember that this module is core. Yes, because also you will learn in your level 5 the module called Develop Database. Yes, now you are required to understand very clearly this module, which will talk about basics and fundamentals of database. By the end of the module, the trainee will be able to, yes, we have elements of competence which are considered as learning unity. The learning unity number 1 is talking about analyze database requirements, and the performance criteria, they are also called learning outcomes. The learning outcome number 1.1 is called proper definitions of database key terms, types of database models, and relationships, database relationships. 1.2 is about proper review of organizational and task requirements to identify user requirements. 1.3 is proper determination of the information that the database is required to hold. Now, learning unit 2 is about design database with 3 learning outcomes. 2.1, adequate design of an entity relationship diagram, ERD. 2.2, proper identification of constraint. And 2.3, adequate development of data dictionary. And the last learning unit, which is number 3, also it has 3 learning outcomes. 3.1, proper creation of tables and attributes. 3.2, proper creation of views. 3.3, proper management of access control of database. Now, welcome. Let's go quickly. I'm not going to talk about I'm not going to cover the whole module, but it is like an introduction, but I would like to cover at least this learning unit 1 in this tutorial. Learning unit 1 is called Analyze Database Requirement. Yes, before defining database, first of all you have to know different database key terms for better understanding what is database after. Yes, the first term is called data. Data is a collection of facts and figures that can be processed to produce information. It means something that you have, but they are not enough to produce information, are called data. Now, to get something which is information from that data, yes, it will require to process that data, yes, to get something. Is to know what is the meaning of that data. Yes, the information now, the information briefly is the meaningful data after being processed. But now let's see the definition. The information is data that has been interpreted so that it has a meaning for the user. Yes. And what about the knowledge? Knowledge, generally knowledge is the result of perception, learning and reasoning. Means the way you are thinking, the way you are the way you are learning, the way you think shows that you have knowledge. And now from here, from this general meaning of knowledge, you can say that knowledge is a combination of information, experience and insight that may benefit the individual. What does it mean? When you have information, the information can produce knowledge. Yes. Let's see this figure, how explain is well. Data is applied for a purpose to produce information, and the information is built and processed to produce knowledge. In that way, that is the meaning. And data in the context of database means all items that are stored in data in the context of database describe or refers to all the single items that are stored in a database. And what about the database now? Database is a collection of related data organized in a way that can be easily accessed, managed and updated. It means a collection of related related data. In other words, database is like a repository where related data are collected. Yes, and where they are, they can be easily accessed, managed, and updated. We will see different examples of database, like a school database here. Like a school database means it is a repository where all information, all data about the school are put. Yes, this is in an electrical way, not in manual system where you can find different records of the school in files, yes, on papers, and you have a cardboard, yes, cardboard full of files. No, here it is a system. Yes, database is a system. It's like a system. Another term used in database called entities. An entity can be a real world object that can be easily identifiable. For example, in a school database, students, teachers, classes, and courses can be considered as entities. Yes, we are going to know very well what about entities when we are going to reach on the unit number 2, where we design database, because these entities with the attribute, we're going to see what is attribute. For further, they will be converted into tables, and these tables will be connected, yes, relationship, to produce a database. Yes. Yes, all these entities have some attributes or properties. It means that attributes are the properties of entities, and then those properties give the entities their identity. Yes, the representation of entities is by using rectangles. Yes, as you see here, student, this shape is rectangle, student, teacher, and project. Now attribute, simply attribute are properties of entity. Yes, means that entities are represented by means of their properties. For example, a student entity may have name, class, and age as attribute. Yes. There exists a domain or range of value that can be assigned to attributes, a data domain. And what is about the data domain? Data domain refers to all values which a data element may contain. The rule of determining the domain boundary may be as simple as data type with an enumerated list of values. Yes, when you are creating you are assigning attributes to entities, and when you are designing the database, think about the attribute, the data domain, that which is the values which a data element may contain. What does it mean? We are talking about the data type here. A data type, as the name is, it is the type of data which database will contain. Yes, the data type. We are going to see this data type here, down here. Data type in details, determination of data. We need to see what is data type, what is the role of data type. But simply, data type describe the types of values or data which will be contained in database table. Yes, now the attributes are represented by means of ellipse. Yes, it is underlined, the ellipse, while entities are represented by rectangle. Good. Let's see the shape. The shape there, entity student here, and now we have roll number, which also can call it student number or number only, or student ID, but roll number it is like that. Name and perfect. The shape on the attributes are ellipses. There are different types of attributes now. Yeah, we have simple attribute. Simple attributes are atomic values which cannot be divided further. It means that you cannot find attribute from the date attribute. I'm going to see what I'm saying on the composite attribute. Simple attribute, it is an attribute in which cannot be divided for further. For example, student phone. If it is a student phone, means that attribute cannot have a derived attribute. Yes, it is simple. It is on that attribute. But here, for composite attribute, we see that an attribute can be divided or can be made by more than one simple attribute. For example, when I'm designing a database and then you say that for here student name, you can complete the name, for example, Motes Jane. Do you see Motes Jane? But if you specify that it is name. Another one can say a first name and last name, and then in the first name you may put Jane, and in the last name can put Motes. Yes, do you see? Composite attributes are made of more than one simple attribute. And now here we have derived attribute, which means we have an attribute, but in a physical database you cannot see that attribute. For example, yes, there are attributes that do not exist in a physical database, but their values are derived from other attributes present in the database. For example, you can build a database, and here you for example, age can be derived from date of birth. Yes, when you write date of birth, and for example someone can write 1989. 1989, this is the year of birth, the year in which she was born, but is not typically the age. But you may calculate the age from this year to the year in which she was born. Means that if you have date of birth, but from date of birth you have the age calculated. Even here you can write, for example, 18 March 1989. That's the date of birth. And now from that date of birth you may also find out the age that someone has. Yes, this is the derived attribute. If attributes are composite, they are further divided in a tree-like structure. Every node is then connected to its attributes. Also, derived attributes are represented by ellipses because also they are attributes. Yes, see here. Student, it is the entity. Roll number, birthday, but here name it has derived attribute, which is first name and the last name. Another term is called the record. A record, they appear as a row in database table. Yes, as you know, a table has rows and columns. These columns are constant as a value in a column is considered as a field. And then, for example, you have a database table with 5 columns. Yes, the information of a single item, the full information of a single item is called record. Yes, also we're going to see down. I'm going to see here. Also, it is indicated here. It is indicated here. We're going to see them very well here. Look, we're going to explain them here on this running out command.3. Yeah, so and we will explain them by using this table. You are going to understand very well what is a record, what is a table, what is field. But briefly, the records, it is information. A record is composed of fields and contain all the data about one particular item in a database. Types of database models now. And what is database model? Database model defines the logical design and structure of database and defines how data will be stored, accessed, and updated in database management system. Do not think about database management system. Also, I want to discuss in details database management system and the learning unity 2. But database model yes, helps to know or to design the structure of database in a logical way. These types, there are 4 types of database models. Yes, 4 types of database models. 4 types of database models. 4 types of database models, which are hierarchical model, network model, relational model, and object-oriented model. These are 4 types of database models. Now let's start by hierarchical model. From the name, we understand the term hierarchy. This database model is organized into a tree-like structure with a single root to which all the other data is linked. Why is it called the tree-like structure? The structure of a tree means a tree has roots, stem, branches, and leaves. Yes, stem is attached to roots, branches are attached to stem, leaves are attached to branches. Yes, this is how also hierarchical model is called. And this model, we have a child node which will only have a single parent node, which we're going to see here. And the relationship here is one-to-many relationship. And do not think about those one-to-many relationship. Also, we are going to discuss more with typical examples of different types of database relationship. Yes, relationship in database concept. But here let's see this hierarchical database model we can use to design. For example, we're going to design the school database or the college database. This here we have the college, and the college will have different departments and an identity of infrastructures. And the department will have different courses, different teachers, and different students. And also in the course we may have courses which are theory and courses which are practical. We are here, they can be used in labs. Yes, this is a single lot, and also these are called the child nodes, which are connected, all of them, to the single lot, which is the college of the school. Yes, network models. Here, network models, the child node, or yes, child node may have different load. Here, this an extension of the hierarchical model, and this model, please know this, in this model, data is organized more like a graph, and they are allowed to have more than one parent node, as I said. This database model was used to map many data relationship. It means that it is when we have here node can have more than one parent node. If it have more than one parent node, means you have many relationship. Do you see? This is the first node, which can be considered as an entity A, parent node A, which has other entities connected to it, B1 and B2, and B1 also has C1 and C2, and then B2 also has the entity called C2 and C3. And you see here, this C2 does not have a single parent node. Yes, C2 has B1 as a parent, whereas B1 also has a root of A. You see, that is the network. Here there is a network between here connected. There is a network. Yes. The third one is called relational model. What you have to know is that relation, the term relation simply means table. Yes, relation simply means the table. Relational model means data is organized in two-dimensional tables, and the relationship is maintained by storing a common field. It means that there must be the common field. That field will be the primary key and foreign key. We are going to see after. Yes, this model has been most widely used database model after being introduced in 1970. In fact, you can say that is the only database model used around the world. It means that these days, this relational model is most useful around the world. Yes, the basic structure of data in relational model is a tables. Yes, it's tables. All the information related to particular type is stored in rows of a table. As you see here, yes, let me try to can see well. Yes, as you see here, we have student ID, name and age. This is the table of student. This is the subject ID, name and teacher. It means that we have the table of subject, and then we have marks, which has student ID and subject ID and marks. Means that this table is created from these two tables. We are going to see when we will reach on the learning unit number 2, design database, and learning unit number 3, where we will build now a database. This now, even here I can explain what is now a record. We have student number 1, 2, 3, 4, meaning that we have 4 records, where and then a field is a part of a record, means that here, for example, 17 is a field because it's a part of this record of student number 1, who is Akon. You see, now this is one. This is the information of the student number 1 is a record. Now let's come back to show how data are represented in tables. Now do you see, to get the marks of student, to know the student and the subject and even the marks that the student got, we use this student ID and the subject ID, and those are called foreign keys, because this table is created from these two tables, and we know then. We will know it very well when we will start the learning unit number 2. Student ID is called primary key, subject ID is called primary key, but here student ID and subject ID, they are foreign keys. Now you cannot understand this by now because we are at the starting point of this module, but as we're going forward, you will start understanding when also we start making practices. Object-oriented model, data is represented in the form of object as used in object-oriented programming. I'm not going to talk more about this object-oriented model because you know that the object-oriented programming, yes, you learned more about this object-oriented programming in your module of programming fundamentals, I think, in the first term. But what you have to know is that in object-oriented database, information is represented in forms of object as they are represented also in object-oriented programming. It is enough. Now let's see about database relationship and what is the meaning of relationship. Relationship is association between entities. Only that. When we don't have relationship between entities, we cannot update, we cannot delete, we cannot access, cannot retrieve data in our database. Means that relationship is very important in database design and database development. Now let's see types of relationship. We have 3 types of relationship. 1-to-1 relationship means one entity is associated with only another one entity. For example, here we have in employees table. We have employee who is associated with one department. Yes, each employee is associated with one department. Above, employee may give support in another department, but he must have, yes, he must, that employee must be located in only one specified department. Another type is one to many, means that one entity is associated with many other entities. For example, a company is associated with all working employees in one branch of the country. Means that we have only one company, but that company has many employees. You can find these either in a branch, in the office, or all across the country. One company has many employees, and many to many relationship means many entities are associated with many other entities. Let's come back also in a company. Many employees are associated with multiple projects. A company have different projects, and then we may have many employees who are working also on different projects. Yes, that's all. Now this is the end of the first learning outcome. Now let's see about learning outcome number 2, review organizational and task requirement to identify user requirement. Here, remember that when you are developing a database will be used by different users. Yes, now we will not imagine what will be in the database. No. First of all, you have to know the needs, the requirements, the data that different users or that database users will need. That is why you need to do data collection. Data collection is the systematic approach to gathering and measuring information from variety of sources to get a complete and accurate picture of an area of interest. And what is the area of interest? Is to develop database. Yes, to develop database. Now you will need to do a systematic approach now to gathering and measure information from database users. The one method is called interview. I think interview, you know about interview, but simply the interview is the conversation between two or more peoples. No, sorry, the conversation between two or more people, not peoples. People does not exist. Yes. Interview is conversation between two or more people where your questions are asked to a person to get the required responses or answers. Means that only you talk with the one from whom you want to know information or you want to get information. And when the one who is asking question is called interviewer, and the one who is providing answers is called interviewee. The second method is called observation. Observation means observing, means watching, means overseeing. Yes, it's the way of gathering data by watching behavior, event, or noting physical characteristics in their natural setting. Means that you reach the place and then you oversee. You watch how things are happening, and then you can take notes of what you are seeing. Yes, questionnaire is a research instrument consisting of a series of questions for the purpose of gathering information from source. So questionnaire is used where you can develop a set of questions and then you give different question papers to respondent, and then they will write the information. There are different types of questionnaires. We have different types of questionnaires, which are close-ended and open-ended questionnaire. Yes, types of questionnaires. They are close-ended and open-ended questionnaires. Yes. Close-ended questions here, they are defined as question types that ask respondents to choose from distinct set of predefined responses, such as yes or no, or among a set of multiple choice questions. Means that you, as the researcher, you developed question, and for every question you provide possible answers where the respondent will choose among provided answers. This is open, this is close-ended. And now about open-ended. Open-ended, there are questions in which possible answers are not suggested. What does it mean? It means that for here the respondent answers it in his or her own words. Yes, there is no limit of answers, there is no possible answers in open-ended questionnaire. The one who is providing the answers will give answers in his own word. Yes, the fourth one is documentation, and documentation is consisting by reading books, searching on the internet, reading magazines to information of the interest. Means that you are reading the writings of others, but on the topic related to your topic. Yes, now let's see database requirements. Yes, requirement, in other words, there is can be defined as the needs requirement. Database requirement. Yes, we have functional requirement and non-functional requirement. And what is the difference between them? Functional requirement describe what. Describe what a database or system should do. Why non-functional requirement? Place constraint on how the database or system will do. Yes. Non-functional requirement is concentrated on the performance of the database, while functional requirement focuses on what to do, what the system will do. For example, here you might develop a database and say that when this process is ended, please send email. Means that an email is a part of the functionality of the system, but the email can be received just if not later than 60 seconds, or the email can be sent after 1 hour or 12 hours. That is not functional, it is non-functional, because you can receive an email in 1 second or 12 hours after. but you will receive the email. Yes. Let's give you a typical example. For example, when you will use your bank account, there is what you call SMS banking. SMS banking means that when there is a transaction made on your bank account, just you are notified by SMS. You can, yes, that notification is a part of functional requirement, because the user, the owner of the bank, will need to have notification about his or her bank. But you can receive an SMS banking just a minute after the process or the transaction is done, or we can receive the notification one day after, or in 5 hours. Just the importance is that you will get the message, you will be notified, but the time it will take, this is the part of the performance, and it is non-functional. Yes, good. I think it is understandable. Now let's come lastly to the learning outcome 1.2 called determine the information that the database is going to hold. Here we're going to talk about database element, and the first element is a table. The second one is a record or law, records or laws. Then another one is field. Table, as you know, table is composed by rows and columns. Yes, and when we are designing database, it will be different when we're going to build it. On the learning unit number 2, design database, we will use what we call entity relationship diagram, where we will make a graphical representation of entities and the relationship between these entities, and each entity also will have its attributes. But when we wish to start building or constructing or establishing the database, the entity will be the table name, and attribute will be the columns, and then from there we'll have a table. Yes, that is why database table is composed of records and fields that hold the data. And here records, there are no here fields, there are the space where we will put values in different columns or values of different attribute. But record, as here it is written, record is data is stored in records. A record is a composed of field and contain all data about one item or one particular item in a database. Yes, and then here field is a part of record and contain a single piece of data for the subject. Let's explain by using this table. Now let's show you by using the employees table below. Yes, we are going to see attribute, field, and record. Here on table employees, this is the whole table, and as you see, we have employees table, and we have the first attribute called, or this attribute ID or identity of the employee, name, age, and salary. These are the attributes, and for now they are columns. Yes, now record is the whole of this. The all information of an employee is record. And the record number 1, the record of the first employee, that employee has the ID 1, name is Jane, age is 25, and salary is 16,000. And then one value, either 25. This place is called field because it is a part of this record. Yes, I think it is understandable. Now let's see the last point of determination of data type. Data type is associated with the specific storage format and the range constraint. And what is the role of data type in database table? Data type will specify the type of data that will be held in the database table. Meaning that if we specify that in that field, we need to hold only the data in types of numbers. Means that when we type a letter or simply text, it cannot be saved. If we specify that field will contain only text data, yes, data in the format of text. If you type number there, it will not be saved. I think you understand the importance of data type. Please specify the types of data which will be saved, or that the database table in the specific field will be held there. Yes, simply, briefly, data type specifies the type of data to be saved in a specific field. Yes. Now see here what I said. Basically, it defines data types. That data type defines how data is stored, handled and treated during the data storage and processing. Yes, this law explains very well the importance or the role of data type. Let's see some examples of data type. I'm going to talk only 3, not more, because there are many different data types. We will see them when you will start practices on learning into number 3 and even number 2 when you are designing, because you develop what you design it. One is character data type. This is basically store alphanumeric characters. What does it mean? All data in the format of text, yes, which are not numbers, can be stored by using character data type. And number data type, of course, number data type will allow only numbers to be stored. Yes. Then date data type. Also here, date data type will only allow the data in the format of date to be stored in database table. Now, thank you for taking our time to see this tutorial. Yes, now here there is your home assignment that you are going to do yourselves, is to know or to see whether you get something. Question number 1, define the following terms used in database concept: data, information, knowledge, field, record, entity, attribute, table, and database. You have to try to define all of these. Question number 2, list and explain 3 methods of data collection. differentiate open-ended questionnaire and closed-ended questionnaire. What is the difference between functional and non-functional requirements? Question number 3. What is the importance of specifying the data type? List 3 of data types do you know? Question number 4. Briefly explain any 3 of database models. And then the last question is about define relationship and write different types of relationship in database concept. For next, maybe we shall have the normal classes by the grace of God. We shall continue with this learning unit number 2 called design database. This is learning unit number 2. We'll continue with it. Design database. We'll see more about the database design here. Yes. Now continue praying God such that this coronavirus can have end, such that the student you may come back to the normal state of learning, where we should have also classes as usual. Now, thank you. May God bless you.